This tutorial will cover setup for using the Google Cardboard with Unity and using simple gaze-based interactions. Google Cardboard works with most smartphones, both Android and iOS. So the first thing you want to do to build for Cardboard is to add modules to your Unity to allow you to build for Android and iOS. To do that, you go to the Unity Hub, and on the Installs tab, you'll find the version of Unity that you plan to use. And from the three dots drop down in the corner, you'll choose Add Modules. Here's where you choose Android and iOS build support. For Android, it's important that you toggle open the little caret next to it and check both the Android SDK and the OpenJDK boxes. iOS only has the one checkbox. One thing that's important here is you only need the specific modules that you are building for, but if you have a team and someone on your team is building for Android and someone on your team is building for iOS, everyone on the team will need to check both boxes, because as soon as you've made a build for one or the other, Unity has some specific files that it adds to your project that will cause the project not to work on other people's computers if they don't have those modules. So if your team is only using Android and every person on the team is using Android, you can just check Android. But as soon as you have someone using Android and someone using iOS, you'll want to check both boxes. You can always just check both just to be on the safe side. There's nothing wrong with having build support for both. One thing to be aware of if you're building for iOS is that you will need a Mac that can have Xcode installed. A Mac with Xcode is required to make iOS builds. Another option for iOS is to use the Unity Cloud Build service, which does cost money to use. But if you have a Mac with Xcode on it, that is the simpler route to go. When you have installed both modules through Unity Hub, you should see them on the version of Unity that you are using as these little icons at the bottom. Make sure it is for the specific version of Unity that you are using. If you switch Unity versions, you'll need to install the modules separately for that Unity version. One issue that sometimes comes up with the Android build support is depending on the permissions that your computer has, like for example, if you don't have admin access on your computer, sometimes it can lose the reference to where it installs those modules. And so if it ever complains that it doesn't have a reference to the Android SDK, if you go to Preferences and External Tools, here's where it points to the installed Android SDK tools. And all of the boxes should be checked. If the boxes are checked and it is still giving you an error, the error would sometimes pop up down here saying missing Android SDK. One thing that you can do is you can uncheck the boxes and click in the SDK field here, and it will attempt to refresh where it's looking for them. And so I normally just will click in this box and let it refresh, and then I'll recheck the box. And I would do this for all three. It doesn't seem to have Android NDK installed, but that shouldn't be a problem for what I'm showing today. If you continue having trouble getting it to locate the Android SDK, what you can do is you can manually browse to where your version of Unity is installed and where it should be looking for that SDK. So you'll have to find your Unity install and locate the Android SDK tools there. I've generally not had to go that far. Just unchecking and rechecking the box refreshes it for me. So the next thing we want to look at is the build settings for the Google Cardboard. And for this demo, I'm using Unity 2019.2. And this is important because in 2019.3 and later, they did change how the build settings works. And a fair amount of how the Google Cardboard works does not currently have an easy integration in 2019.3. Google and Unity have both said they're working on the integration, but right now it does not seem to work correctly. So I will be using 2019.2 to demonstrate this, and I do recommend that version of Unity specifically for building for Google Cardboard. So I'm going to go to my build settings, and as with any Unity project, you would want to add open scenes to add whichever scene you're working in. And here we have iOS and Android as the possible build platforms that we could be using. Before I pick either of those, what I want to do is I want to go to my player settings, which will open this new window here. And under player settings, there's a couple things when building for mobile that you need to be aware of. The company name and product name need to be set to whatever you want to call them. It doesn't really matter what you call them, but you do need to put something in the company name and product name slots. And you'll want to make sure that under the other settings, if you scroll down to package name, you want to make sure that this package name matches the ones you have listed above. So it should be the format com.company.product. And so this company and product need to match the company and product at the top. And you'll want to do that for both the Android tab and the iPhone tab, and that's under the other settings. So make sure that they both match. In Unity 2019.2, this does happen automatically, but in older versions of Unity, you did have to specify this yourself. A couple of other settings that you'll want to adjust on the Android tab, also in the other settings. If you scroll down to minimum API level, this minimum API needs to be 4.4 or higher to work with the Google Cardboard. This is the Android OS that's running on the phone, so this will not work on phones that are using older than Android 4.4 for the OS. On the iPhone tab, also in the other section, for minimum OS version for iPhone, it is recommended to use 9.0 or higher. This is an Apple recommendation. If your phone that you're using is older than 9.0, you may still be able to set this number lower and build locally, but probably you would not be able to submit that build to Apple, because currently Apple is expecting iOS version 9.0 or higher. The last thing we'll need, and we'll do this for both Android and for iOS, is to allow virtual reality. And if you scroll all the way down under player settings into the XR settings and open that up, and all you have to do is check this box, virtual reality supported. It will show you an empty list. And if you hit the plus button under that list and choose Cardboard as your SDK, this is built into Unity, so you don't need to download or install anything. You simply add the Cardboard SDK under this virtual reality supported section, and this allows you to build for the Cardboard platform. And you'll do the exact same step for iOS. Remember, this is important. If anyone on your team is using Android or iOS, you'll need to do both of these and make sure they're both set up correctly. So I'll check the box for virtual reality supported, and then with the little plus, I'll add Cardboard. One thing that you'll also need to do for iPhone specifically is there's recently been an update to one of the built-in Unity packages, and it conflicts with the Google Cardboard for iOS. So if you go to Window and then Package Manager, and then wait for this list to refresh and scroll down to Google Resonance Audio. So Google Resonance Audio had an update, and the 1.2 version of the update does not work with the Google VR iOS. So if it shows you 1.2 here as your version for Google Resonance Audio, you can select one of the older versions from the list below and hit this update to, and it will take you back to that previous version. So 1.1.8.3 is the version that I'm using, and this version seems to work with the Google Cardboard iOS SDK. So all that's left to do now is to build for the phone that you have. So back in build settings, you'll choose iOS or Android. And what you want to do is you want to make sure that you have your phone plugged into your computer by USB. If you're using Android, you will need to set your phone to allow developer mode. This is different for every Android phone, so you'll just need to Google it for your specific phone. And make sure that you allow USB debugging, which is under the developer settings on your Android phone. That is specifically for Android. If you have trouble putting your Android phone in developer mode, the other option for Android is you can just build an APK for Android, and that would build it directly onto your computer, and then you can copy that APK file onto Google Drive or some other cloud service and then download it directly to your phone. So that is another option for Android. For iOS, as I mentioned before, you'll need to be on a Mac that it has Xcode, and you plug in your iPhone to your computer, and the steps for iPhone are a little bit different to the first time you build, because you'll have to set up Xcode to work with your phone and with your Unity version. I don't have an iPhone, so I actually can't walk you through those steps in this video. But once you have done the setup the first time building to your iPhone, you shouldn't need to do those steps again. And so after the first setup, then you can just hit build and run, and it will put it directly onto your iPhone. Once you choose switch platform for whichever phone you're going to build for, you either choose build and run if you have the phone plugged in, or you can hit build. And in my case, my Android phone was not connecting to my computer, so I'm just going to build the APK file, and you give it a name, and after you build it, it will create this APK file, which you can copy to Google Drive or any other cloud service, and then copy it directly to your phone. When you're downloading an app this way, you'll want to make sure that the phone stays awake the whole time that it's downloading and installing. If the phone turns off, it can interrupt the install. It also might warn you that this app is from an untrusted source, and so it will suggest that you not install it, but there is an option to say install anyway, which is what you should choose. When you build this onto your device, whether it's onto Android or iPhone, you will see an empty Unity scene with a skybox, and you will probably see it with sort of goggles overlaid on top of it. And if you put it inside of the Google Cardboard headset and hold it up to your face, it should look like you're looking around this Unity skybox in VR. Now I want to talk a little bit about adding interactions and different ways that you can use the Google VR with some SDKs that are available online. And the first one I want to talk about is from Google, and this is their Quick Start Android guide for Unity. And a lot of their steps here, I have to warn you, are a bit outdated. They put this together for Unity 2018. So pretty much the only reason that I visit this site is to get to the latest Unity package for Google VR. And so if you click the releases page, it takes you to their GitHub where you can download the Google VR SDK for Unity package. So from the GitHub page, you just scroll partway down to this one right here. This is the latest one. And so you download this Unity package, And to import a package into Unity, if we pop back to Unity, we would go to Assets, Import Package, Custom Package. And then you browse to where you downloaded that Unity package file. And this will show you all of the things that it's going to import. And we'll just hit import. When the package is finished importing, we'll have a new folder called Google VR, and we can open that up. And from here, we can go to the Demos folder. And inside of Demos folder, I'm going to go to Scenes, and I'm going to open Hello VR. And I'm not sure where I'm at in the world right here, so I'm going to double click on the player so I can zoom to where the player is at. And so they have this VR room set up that you can use to build and test on your Cardboard. In fact, we could just change our build settings and choose Add Open Scenes and then delete the sample scene, and then we could build this Hello VR scene onto our phone and test in the Cardboard. One neat thing that Google does with this demo is it will automatically work as intended for either the Google Cardboard or for the Daydream. So if you build this and test it on a Daydream, it will allow you to interact using the pointer. And if you build it and test on the Cardboard, it will allow you to interact with the gaze. So it has in the scene, and by the way, the controls in the scene are Alt to look around, and click represents the button on the side of the Cardboard. So this already has functionality to look at an object, and click with the button on the side of the Cardboard to interact. And I did just test this on my phone just now, and when I built it, it had this functionality already set up and working. So this is the simplest way to get gaze-based interaction. And the only thing that I dislike about this setup is the button on the side of the Cardboard. When you press down on it, it actually kind of shakes the headset a little bit because you're pressing a button. And for some people, this can actually make them motion sick because it results in the screen shaking. So I generally like to have interactions that happen based on gazing at an object for a period of time. And I do want to clarify here that gazing in this case is just based on the direction the user's head is facing. We're not actually detecting where on the screen their eyes are focusing. We are just detecting which direction their head is facing. So I prefer to implement a system that waits maybe 1 or 2 seconds while they're staring at an object and has some kind of color change or particle effect happening on the object, or maybe a bar filling up that lets them know how long they've been staring at that object. So this functionality, like I said, is built, the gaze and the button press is built into the Google VR SDK. I do want to point out that there is an issue with the Google VR SDK and Apple right now that should not stop you from building locally on your own phone. But if you were to attempt to publish this to the Apple Store, there is an issue with some of the code that is being used in the Google VR SDK that would not allow you to publish to the Apple Store. So I do want to share one alternative to this, which is an option from Durivos. And it used to be called Open Dive Sensor. It was originally an open source project that it uses the gyroscope in the phone, and it just sort of doubles the camera view and adjusts based on, moves the cameras around based on the gyroscope in the camera. Here's an example here. showing a VR roller coaster, which I would say is a really bad idea design-wise, but it demonstrates really clearly how the camera and the gyroscope works. So this is another option if you download this. This is also a Unity package. Generally, you don't want to use two separate plugins that might conflict in some way since they would have some similar functionality. So you would use this instead of the Google VR. And if you were using the Dive plugin instead of the Google VR plugin, I believe you would actually disable from build settings, player settings. I believe you would actually disable VR support here because this VR support is already tapping into Google's SDK. So if you disable this VR support here and just use the open dive sensor, by the way, this page will sort of walks you through a little bit of how to use it. This is not actually called VR in Unity. This is just using the gyroscope. So you would uncheck that VR option. And since it's splitting the cameras, it's showing two different camera views in this example video. You can see that it has two separate cameras. So when you put this in the Google Cardboard, it should look correct. It should look as if you are in VR. So that is an alternate option if the Google VR SDK does not work for you for some reason. So let's take a look at how the gaze-based interaction works in the Hello VR demo from Google. So I'm going to open up this player character and I'm going to select the main camera, and I see they have this script GVR pointer physics raycast. So this is what is attached to the camera that is detecting what the camera is pointing towards. This could also be accomplished on your own if you're using the Dive sensor SDK instead. You could just do a raycast from the camera into the world and detect which object you are looking at. So this is a pretty simple setup that Google gives for you. You would just have this attached to your camera. You could also change which types of things that the raycast is checking for. So if you wanted to, say, for example, remove the UI, if you didn't want the user to be able to gaze at or interact with UI objects using their gaze or something like that. So the camera itself is detecting what things it is pointing at. And then if we open up this treasure game object and we see these are the actual objects that were detecting my gaze when I hit play. And so if we take a look at what is going on with these objects, they have a collider. They also have a script called object controller, and they have an event trigger. And this event trigger has several different inputs here. So it has a pointer enter, pointer exit, and pointer click. And so if you're using this with the Daydream, this would be detecting if you're pointing at this object using the Daydream controller. If you're doing this with the Google Cardboard, it automatically changes that to use the camera as the pointer. And so this pointer enter is when the camera looks at the object. Pointer exit is when the camera looks away. And pointer click, this is when you press the button on the side of the cardboard. If you don't have a cardboard and you're trying to test this, you can also test this by tapping the screen. That also emulates pressing the button on the cardboard. It also has a sound effect object attached to it, but there is no audio clip, so that's why it's not playing any audio right now. So what I'm mainly interested in is this pointer enter and pointer exit, because those are the interactions that I think are really useful with gaze. And so we see when pointer enter, when this event is triggered, it calls the game object itself is dragged into this slot here, and it calls a function on that game object, object controller.setGazedAt. Object controller is this script right here, and so it's calling a function on that script called setGazedAt, and it is sending a value of true. This checkbox here means the value it's sending is true. You can see if you look down here, it's calling the same function but setting a value of false. So it's calling this function to tell it true or false if the user is gazing at the object or not. So let's open up that script. This is the object controller script attached to the object. And here is that function that it's calling, set gazed at, and it's passing a Boolean, true or false. And it's checking if the interactive material is not set to null. So it's making sure it has something set to the interactive material. That interactive material is this public material slot here, and it also has a gazed at material. So it's making sure that there is something set for these two values, otherwise Unity would throw an error. So the script is making sure that these two materials exist, and as long as they exist, then what it's doing is this is some fancy code that is basically saying that if the gazed at value is true, it is setting the gazed at material, and if gazed at is false, it is setting the interactive material. So it's switching which material the renderer is using based on this gazed at Boolean. So we can see that in action if we hit play. And I'm holding Alt to look around, and when my gaze passes over the object, I can see that material changes color. So it's letting me know that that object is highlighted. You might also notice that the pointer for the little dot that is showing the center of my view is changing to let me know when I'm hovering over something. That is some built-in functionality that comes with the Google VR SDK. So what I'm going to do is I'm going to create my own interactive script to detect when the player looks at something, and I'm going to detect how long the player looks at it so I can have something happen after staring at it for a certain amount of time. So that type of functionality, the gazing at, currently is built into the object controller that Google provides, but I'm going to make my own script instead of using the object controller script. I am going to allow the main camera pointer physics raycast to handle the actual gaze itself. I'm just going to change how I am interpreting that gaze. So I'm going to create my own new C# script, and I'm going to call this teleporter because when I have the user stare at an object for a certain amount of time, I'm going to allow them to teleport to that location. This is one of the smoother ways to handle movement that does not induce as much motion sickness. If you have the user actually moving physically around the environment, or particularly if you have them speeding up and slowing down, that can really cause a lot of motion sickness for some users. So I've made this new teleporter script, and I'm going to make a game object, 3D object, cube, and this is going to be where I teleport the player to. And so I'm going to attach the teleporter script to this game object. Now I'm going to reference back to that treasure object that Google used so I can see what all needs to be attached to it. So the things I think my script is going to replace the object controller script. I do need to make sure I have a collider. Cubes automatically come in with a box collider, so that's fine. The other thing that I need is this event trigger, and I'm going to use the pointer enter and pointer exit events. So I'll select my cube and add component, event trigger, and add new event type. And I'm going to use pointer enter and pointer exit. And within each of these, I can hit the plus. And what I want to do is drag my cube game object onto these empty game object slots. Then from the no function dropdown, I'm going to be using my teleporter script, but I have not made a function yet. These are all the default functions that come with a new C# script. I'm not using any of these. I'm going to make my own. So I'm not going to put anything in here just yet. So I'm going to open up this teleporter script that I made, and I'm going to remove the start function. I'm not going to do anything on start. And instead, I'm going to make a new function, and it needs to be a public function in order to be able to call it from another an object in the scene. And so I want to be able to call this from the event trigger, so I'm going to make it public void, and I'm going to call this function gaze at, and I'm going to pass it a bool called gazing, and open and close curly brackets to make it a function. So this is a very similar structure to the set gazed at function that Google is using. They also pass a bool. And you can call the bool whatever you want. So this is a very similar structure to the function that they have set up. So what I want to do now is, if the user is gazing at this object, I want to gradually change the color of the object. I'm not just going to swap the material, because what I want to do is I want to indicate to the player that they need to keep their gaze fixed at that object. So I'm going to make a couple of color variables at the top. If you make these variables public, then you can actually set them in the inspector with a color picker. So I'm going to do public color inactive, and then I'm going to do public color gazed at. So this color gazed at does need to be a different name than the bool. These are both variables, and so I don't want to mix things up by trying to use the same variable name. So do make sure that these variables are all named something different. So if I go ahead and save this script right now and go back to Unity and select my cube game object, I can see that I have these two color swatches here that I can now pick their color. Note that they do default to the alpha being 0, and so I definitely want the alpha to be all the way up to 255. So I'm going to make my inactive color be maybe a purplish color. And I'm going to make my gazed at be a greenish color. And you can always change these colors to be something that's more appealing based on your environment aesthetic. So if I go back to the script, I have just realized that I actually do want a start function. So I'm going to put that below this one. I should not have removed it, so I'll do void start with a capital S. It gave me too many curly brackets and too many parentheses. Sometimes Visual Studio tries to fill things in for you, and you were already typing them, and so you get extra versions of things. So that should be void start with a capital S, open and close parentheses, open and close curly brackets. And so what I want to do on start is I want to set the color of the cube to this inactive color. And I'm going to create another variable at the top. This one is going to be private. And this is going to be a mesh renderer. This is going to refer to the mesh renderer on this object itself. So I'm going to call this my renderer, my meaning the thing that the script is attached to. So the script claims the cube as its own. So it would say my renderer is this cube's renderer. So then in start, what I want to do is my renderer dot material dot color equals inactive, and save that. And let's just test it out real quick and make sure that that part works. It did not work because I did not tell it what this my renderer reference should be. In my start function, before I set the material color for this my renderer, I need to tell it what my renderer should refer to. So I'll say my renderer equals get component mesh renderer. So this gets the mesh renderer component on this object. By storing it as a variable, this makes it so we don't have to get this component every single time we want to use it, which can be computationally intensive for a game. And if you do that too much, if you do get component in your update function too frequently, it can affect your frame rate. So if I go back to Unity, I just want to point out that with the cube selected, you can see this mesh renderer component. This is what the function is referring to. So now when I look over here at this object, I can see that it is lavender. And you'll notice when I gaze at it, it is changing the reticle to this open circle, just like it is with this treasure object. And that's because I have the event trigger set up. So even though my event trigger is not doing anything, just by adding it causes it to interact with the gaze from the camera. If I were to remove that from the cube, let's take the cube and remove this component, event trigger. Now when I look at the object, nothing is happening because there's no event trigger on that object, and so it is not interacting with the camera's raycast. So let's add that back in. Add component, event trigger, add new event, pointer enter, and add new event, pointer exit. Then just like before, we'll hit the plus and drag the cube onto the object slot. And then from that no function, I'm going to choose my teleporter script, which is attached to this object. And I'm going to select gazed at, which is the function that I just made a few moments ago. And I'm going to choose that for both. So it's going to set gaze at from the teleporter script for on pointer enter and on pointer exit. On pointer enter, I want to check the box. So the gaze boolean in my script, this gaze boolean here, this will be set to true when I am looking at the object, and it will be set to false when I am not looking at the object. I'm going to save my scene real quick and then go back to my script. And so in this script, I want to actually do something when I'm gazing at the object. And just to demonstrate how this works, I'm going to check if gazing. I'm going to do this a little simpler than what was set up in the Google function, just to better demonstrate how these booleans work. So if gazing, then I'm going to set my renderer dot material dot color equals gazed at, which is my color that I specified up here. Then I'm going to do an else. So if gazing is true, I set the color to gazed at. If it is not true, I set the color to inactive. And since these are color variables, I actually don't have to check if they're null. I'm going to Control S to save. In Google's script, they are checking if the material, the public material object is set to null or not, because if those materials are not specified in the inspector, then this code will fail. But for mine, since I'm just using a color, the color wouldn't actually be null, it would just be transparent. So this code would still run, it would just not actually change the colors of the objects. So save that, go back to Unity, and test it out. So now when I gaze at the object, it turns green, and when I gaze away, it turns back to purple. So that's pretty easy. So what I want to do instead of immediately changing it is I want to gradually change it to let the player know how long they have stared at it. So what I'm going to do is I'm going to set a private bool, and I'm going to call this color changing. I'm going to set it to false. Now what I'm going to do is in my if gazing, so if the user is looking at it, I'm going to set that set color changing to true. So I'm going to tell it should start changing the color. And in my else, so this means the user looked away, I'm going to set color changing back to false. But I am going to keep this my render.materialColor.inactive. So when you look away, it automatically turns back to inactive. So in my update function, I'm going to check if color changing is true. So if color changing is true, then I want to do something on every frame. So in my update function, this is what happens on every frame. And so I'm going to change the color of the object based on how long the user's been looking at it. So this would be my render dot material dot color equals, and now I'm going to use what's called a lerp, which interpolates between two different values. And so this is going to be color.lerp. Color.lerp is a built-in function that lets you transition gradually from one color to another. So I'm going to transition from, it shows me here what I need to fill in, color A to color B, and how fast I want it to change, or how much time I'm transitioning by. So I'm going to do transition from inactive as color A to, what's my other color called? Gazed at is my other color. So that will be color B. And I think because this is an update, I can use time.delta time. And then make sure you end that with a semicolon. I think actually I've realized I think this should not be the inactive color. This should actually be my current color. So I'm going to use my render.material.color. This gets the current color of the material. So I'm transitioning from the current color to the gazed at color, and transitioning by time.delta time, which is the amount of time that passed since the previous frame. So let's save that and see if it works. So now you can see the color gradually changes to the gazed at color. So it starts out purple and then gradually changes to green. And when I look away, it immediately goes back to purple. And if I wanted to make that happen slower, say, so right now this takes about 1 second to complete. Let's say I wanted it to take 2 seconds. So I could divide by 2, and we want to use 2f, which makes it a float. This causes it to not round the value. So we do want to use a floating point value. And then test that. And now it happens slower. So now it takes 2 seconds to fully transition to green. I could also add a particle effect to this to really drive home the point. So I'm going to add a particle system. And change the renderer on this. The default does not have a material, that's why it's those ugly magenta squares. So we click this circle, and I'm going to use the default Unity particle, and I'm going to change my shape. The default shape is a cone. You can see the outline of the cone here. I'm going to make it a sphere, and I'm going to reduce the start speed. I'm going to change this to 1, and I'm going to give it some negative gravity. This causes things to float upward. -1 is a little too much. I'm going to do negative 0.5. I personally like to use size over lifetime and color over lifetime so that the particles don't spontaneously appear and disappear, which can be a little off-putting. So I'm going to use size over lifetime and color over lifetime. Size over lifetime, I'm going to leave it as it is. Color over lifetime is a gradient, and so what I'm going to do is I'm going to set the start alpha. The alpha is the top handles, the color is the bottom handles. So I'm going to set the start alpha to 0. I'm going to have it come to full in the middle. I'm going to set another handle at the end which has an alpha of 0. So this will cause them to fade in and out over their lifetime. I do also want to reduce the lifetime of these particles. You can see they're going all the way up out of the world because they're living for so long. So I am going to reduce the lifetime to maybe 1.5. Maybe I don't want it to go all the way outside of the world, so I'm going to do 1.25. That looks pretty good. And I'm also going to change the duration to match. I normally set my duration to the same as my lifetime, even though it's looping, so it doesn't really matter. I find it works better to keep those values the same. And then I am going to change the start color. So I'm going to make my start color be green. I am also going to change the start size, just make all of the particles smaller overall. That looks pretty good. And what I want to do is I want to uncheck the box for play on awake. I don't want this to start at the beginning. I only want it to start when I tell it to start. So I'm going to save my changes to the scene, and I'm going to go back to the script. And in my if gazing, I'm going to get component particle system dot play. And that's a function, so it needs an open and close parenthesis. Then in my else, so when I look away, I'm going to do get component particle system dot stop, open and close parenthesis and semicolon. Save changes to my script, and let's test it out. So now I can see the particles start when I look at the object, and they stop when I look away. The particles are actually coming a little bit too far outside of the cube, and I'm realizing with the sort of greenish background, it's not super obvious. So I might want to make some adjustments to my particle system. Maybe I actually want my color to be, let's do yellow. I think yellow will show up well. So we'll do yellow for the particle color, and I am going to change my shape. You can see the shape goes all the way outside the cube, and I kind of want the particles to look like they're coming from inside the cube. So I'm going to change the shape. I'm going to change the radius. Let's do 0.5 for the radius, and I'm going to also make the radius thickness 0.5. Also for my color over lifetime, I think I am going to change the end color. So I'm going to make it go from yellow to sort of an orangish color. So it's going to start yellow, and it's going to gradually become more orange. I am also going to make the opaque alpha a little bit more of the lifetime. So I made both of these have alpha of 255, and I'm spreading them out so that they're only transparent right at the beginning and right at the end. So let's check that out. So that's quite a bit more noticeable, I think. So now I am detecting when the user is gazing at the object. And now what I want to do is I want to teleport the player to that location after they've stared at it for its full duration. So its full duration is 2 seconds. I set that by dividing time.delta time by the total amount of time I want it to take. And so now if I have reached the full color, what I want to do is I want to teleport the player to that location. So in my update function, this will be inside of my color changing if statement, because I would only want to teleport them if they are still looking at the object. So I'm going to actually add a timer in here so I can tell how much time has passed. And I'm going to make a variable at the top of my script for keeping track of that. So we'll do private float, call it my timer. I'm going to set it equal to 0 by default. And while my color changing is happening, I'm going to do my timer plus equals time dot delta time. So I'm adding however much time has passed since the previous frame. And now, if enough time has passed, so if my timer is greater than or equal to 2, then I want to teleport to that location. Before I set up the teleport, I do also want to make sure I reset the timer. So this timer is going to go up continuously while I'm looking at the object. So if I look away from the object, I do want to reset that timer value to 0. So back to my teleport. And what I want to do is I want to move my player to this X and Z location, but I don't actually want to change the Y value. So the Y value of my camera is set up to sort of make the player feel like they have some height. I don't want to set the Y value to the Y value of my cube, because then they would be inside of the ground. So I want to keep the Y value, but I want to take the X and the Z value of the cube. So to do that, in my script, I'm going to make a vector3. I'm going to call it pose for position. And I'm going to set this equal to new vector3. And for my X location, I'm going to use the X location of the object this teleporter is on. So that'd be transform dot position dot X. For the Y value, I want to figure out what is the Y value of my camera. And since this might be controlled in some way by Google, I don't want to hard code a Y value. Instead, I want to get the value of the camera, what the camera's Y value is currently. So up at the top where I have all my public variables, I'm going to make another public variable here. This is going to be a game object, and I'm going to call this player cam. And so then I'm going to come back down to my incomplete vector3 setup, and so this is going to be player cam dot transform dot position dot Y. And then the Z value of my vector3 is going to be for the cube again, so this would be transform dot position dot Z. So this transform dot position is getting the position of the object my script is attached to, which is the cube. So now I have this temporary vector3 that I can use, and so what I want to do is set the value of the camera. And since I just created a public reference to the camera, I can use that to move the camera to my location. So we'll do player cam dot transform dot position equals pose. So we're going to move the player to this position, and I'm going to save that. And I'm going to go into my scene to assign this variable. So with my cube, my teleporter selected, if I scroll to my teleporter script, here is that public player cam slot. Even though I've called it player cam, I am actually going to use the player game object, because the player game object has all of the Google VR stuff attached to it. So I don't want to just take the camera away from the player. I want to use the whole player object. So maybe I should redo my variable. Instead of calling it player cam, I should actually just call it player to be a little more precise. So I'm going to rename it right now so I don't forget. So instead of player cam, I call this player and adjust it everywhere that I'm using it. Save that. And so now when I look in the inspector, I can see that that variable name is now just player. So I'm going to drag the player object onto that slot. And let's see if it works. So now I have moved to this location, and I can still look around and gaze at other objects. So that's one of the easiest ways to handle teleportation movement with the Google Cardboard. I do just want to double check and make sure that if I look away before it finishes, that it does not teleport me, because it resets the timer. Okay, that looks good. So now I would just want to have multiple of these objects around the scene. I could even do that right now to test it. So I'll just Control D to duplicate, or Command D on a Mac. Now if I look at any of these objects, I can teleport to them. And I can use this to move around the scene. So this makes it possible to interact with objects in different locations around your environment. I hope you found this tutorial helpful, and I look forward to seeing you in the next one.